Hello students, your teacher here, Mr. Sarasinski, with another episode of Algebra 1, Lesson 5.4, Solving Systems of Equations using the Elimination Method, Day 2. And in today's lesson, we're going to be solving systems of equations using elimination where we can't just simply add or subtract the equations to get one of the variables to cancel out. We're going to have to do a little more work to get that opportunity. And so, let's start out by answering this question. What if there are no common coefficients? So in the last lesson, there was one common coefficient, and so we just had to decide if we would add or subtract to cancel it out and then solve for the other variable. In this lesson, we're going to have to multiply one of the two equations or sometimes both of the equations by some number in order to get one of the coefficients for one of the variables to cancel out. Okay, here we go. What if there are no common coefficients? Multiply one or both equations multiply one or both equations by some number to create matching / opposite coefficients. Okay. Example 1. We need to get one of these variables to cancel out with the other equation. And after quickly observing these equations, I noticed that I can multiply this top equation by 2, and then I can subtract the equations, and the x term will cancel out. So I'm going to do that. Multiply this entire equation by 2. I'm going to get 2x plus 6y equals 12. And then I'm going to subtract it from this other equation to get the x values to cancel out. So 2x minus 2x, that's 0. 6y, and this is minus a negative, so it changes to a positive. This is 13y, and then this is minus a negative again. 12 plus 1 equals 13. All right, so we got the x's to cancel out. Now we need to solve for y. The 0 goes away, divide by 13 on both sides, and y equals 1. Once you have one variable solved for, substitute that value into either equation. I'm going to use the first equation and solve for the other variable. In this case, we have y, so we're going to solve for x. 3 times 1 is 3. Bring everything else down. Subtract 3 from both sides, and x equals 3. So the solution to this system of equations is 3, 1. Number 2. After observing the equations, I notice that I can get rid of the y's by multiplying this second equation by 3. Compare that to the x's. If I wanted to use the x's, I would have to multiply the second equation by 4.5 in order to get the x's to cancel out. Or I would have to multiply both equations by 2 and 9 respectively. And I don't want to do that. I want to create as little work as possible for myself. Okay, so multiply the bottom equation by 3. What do you get? You get 6x plus 3y equals 15. And then in the top, I'm just going to bring that over. 9x plus 3y equals 12. And now I'm going to subtract. 9x minus 6x is 3x. 3y minus 3y is 0. And 12 minus 15 is negative 3. The 0 goes away, and I have 3x equals negative 3. Divide by 3 on both sides, and x equals negative 1. If x equals negative 1, what does y equal? Well, I just have to plug it back into one of my equations, and I'll choose the first equation. 9 times negative 1 plus 3y equals 12. 9 times negative 1 is negative 9 plus 3y equals 12. Add 9 to both sides, and 3y equals 21. Divide by 3 on both sides, and y equals 7. So the solution to this system of equations is negative 1, 7. Number 3, I am going to multiply the top equation by 4. If I multiply the top equation by 4, then my y terms will cancel out. And I can cancel them out just by adding the two equations together. So 3x, because they already have opposite signs. It's going to be 12x minus 3y equals 56. This should not be 3y, this should be 4y. There we go, get that fixed. All right, now bring the bottom equation over. And I'm just going to add these two together. And I'm doing that because the y terms already have opposite signs. 12x plus 5x is 17x. Negative 4y plus 4y is 0. And 56 plus 12 is 68. 0 goes away. I have 17x equals 68. Divide by 17 on both sides. And x equals 4. If x equals 4, I can plug it back into one of my equations and solve for y. 3 times 4 is 12. Subtract 12 from both sides. Divide by negative 1. So the solution to my system of equations is 4 comma negative 2. All right, number 4. So in number 4, I have the choice. I can multiply the first equation by 5 and cancel out the x terms, or I can multiply the first equation by 2 and cancel out the y terms. And I think I'm going to choose canceling out the y terms because then I can add the equations together and I don't have to worry about changing the signs in the second equation. So I'm going to multiply the first equation by 2, and that gives me 2x plus 2y equals negative 6. And then bring the second equation over, 5x minus 2y equals negative 50. And I'm going to add these equations together. So 2x and 5x equals 7x. 2y plus negative 2y is 0. And negative 6 plus negative 50 is negative 56. All right. The 0 goes away, and I have 7x equals negative 56. Divide by 7 on both sides, and x equals negative 8. If x equals negative 8, then I can plug it into one of my equations and solve for y. I'm going to plug it into the first equation. All I have to do is add 8 to both sides, and y equals 5. So the solution to this system of equations is negative 8, 5. Number 5. I'm going to multiply the second equation by 3. and that will allow me to subtract the two equations and get the y's to cancel out. So this would be 6x minus 3y equals negative 5. And then 3x minus 3y equals negative 3. And I'm subtracting, so I have to change the signs of any negative numbers in that second equation. All right, 3x minus 6x is negative 3x. Negative 3y minus positive 3y is 0. And negative 3 minus positive 5 is 2. All right. I'm sorry. In the second equation, I need to correct something really quick. This should not be 5. This should be, because I multiplied by 3, this should be 15. Okay. And this will be 12. Okay. So 0 goes away. Divide by negative 3. And x equals negative 4. If x equals negative 4, let's plug that into our first equation for x and solve for y. 3 times negative 4 is negative 12. Let's add 12 to both sides. Divide by negative 3. So the solution to this system of equations is negative 4, negative 3. All right, a few more examples. Number 6. I can multiply the first equation by 2 and cancel out the y terms by subtracting the two equations. So let's do that. I get 6x plus 2y equals 4. And then we're going to subtract 6x plus 2y equals 4. And when I subtract, everything cancels out. And what I'm left with, 0 equals 0, is a true statement. If everything cancels out when you're solving using elimination and you're left with a true statement, infinite solutions, that means these lines are overlapping. Okay. Number 7. It looks like I can multiply the first equation by 2 and get the y terms to cancel out. So 6x plus 8y equals 12. And I'm going to subtract 7x plus 8y equals 10. All right, 6x minus 7x is negative 1x. 8y minus 8y is 0. And 12 minus 10 is 2. 0 goes away, and negative 1x equals 2. Divide by negative 1 on both sides, and x equals negative 2. If x equals negative 2, we can plug it into the first equation for x and solve for y. 3 times negative 2 is negative 6. Bring everything else down. Add 6 to both sides to get rid of it. 4y equals 12. Divide by 4 on both sides. And y equals 3. If y equals 3, then the solution to this system of equations is negative 2, 3. Number 8. In number 8, this is the first time that we are going to have to multiply both equations by something in order to get one of the variable terms to cancel out. And we're going to use the y terms. And you can see 3 and 4 I need them to both equal 12. So I'm going to multiply the top equation by 4 and the bottom equation by 3. Then I'm going to subtract the two equations to get the y term to cancel out. So let's see what this looks like. 12x plus 12y equals 36. And 15x plus 12y equals 30. Okay. Now I'm going to subtract. So 12x minus 15x, that is negative 3x. The y terms cancel. And 36 minus 30 is 6. The 0 goes away. Divide by negative 3 on both sides. And x equals negative 2. If x equals negative 2, then I can plug it back into one of my original equations, not after I multiplied, but one of my originals. And 3 times negative 2 plus 3y equals 9. 3 times negative 2 is negative 6. Bring everything else down. Add 6 to both sides. 3y equals 15. Divide by 3 on both sides, and y equals 5. The solution to this system of equations is negative 2, 5. Number 9. I want you to pause for a second and think, what would be the easiest term to cancel out here? We're going to have to multiply both of these equations by something to get one of the variable terms to cancel out. And I think, after reflecting for one moment, that this set of variable terms will be easier to cancel out because it'll be smaller numbers. And all I'm going to do is multiply by the coefficient of the opposite equation. So I'm going to multiply this top equation by 7, which is the coefficient of the variable term in the second equation. And I'm going to multiply the bottom equation by 5, which is the coefficient of the variable term in the first equation. That's a mouthful. Okay, here we go. 35x plus 63y equals negative 70. And then 35x plus 50y equals negative 5. And I'm going to subtract these two equations, so I will need to change this negative 5 to a positive. All right, 35x minus 35x is 0. 63y minus 50y is 13y. And negative 70 plus 5 is negative 65. Okay, the 0 goes away, and 13y equals negative 65. Divide by 13 on both sides, and y equals negative 5. If y equals negative 5, then I can take it and plug it back into one of my original equations to solve for x. So 5x plus 9 times negative 5 equals negative 10. 9 times negative 5 is negative 45. Okay, add 45 to both sides, and 5x equals 35. Divide by 5 on both sides, and x equals 7. So the solution is 7 comma negative 5. Number 10, I'm going to multiply by 2 and 5. So I'm going to multiply the top equation by 5, multiply the bottom equation by 2. And I didn't choose to multiply by negative 5 because I want the signs to stay opposite. Then I can just add the two equations together and get them to cancel out. But, okay. Let's go ahead and multiply the equations. I also am noticing in this moment that our equations are not aligned. The equal sign is not in the same place for each equation. And so I will need to move in the first equation, I'll need to move the y term to the other side before I can begin to solve this. So one thing at a time though. First, let's multiply. So this will give me 10x equals 20y plus 80. Is that 80? No, it's 90. Okay. And then negative 10x minus 12y equals 6. All right. Now I need to move this first equation around, and I'm going to subtract 20y from both sides. So I get 10x minus 20y equals 90. Okay. I'm going to add these two equations together since my x terms already have opposite signs. Negative 20 plus negative 20y plus negative 12y is negative 32y. And 90 plus 6 is 96. Divide by negative 32 on both sides, and y equals negative 3. If y equals negative 3, I can plug it back into my original equation and solve for x. 4 times negative 3 is negative 12. Negative 12 plus 18 is 6. Divide by 2 on both sides, and x equals 3. Solution, 3, negative 3. All right, number 11. Similar problem. I'm going to multiply by 3 and 2. After I multiply it, so this will get my x terms to cancel out when I subtract the two equations. And then I'm also going to have to move the terms around. I'm going to have to move negative 6y to the other side of the equation in order to get the equations in alignment. All right, here we go. 6x plus 12y equals 18, and 6x equals 24 minus 12y. In order to move 12y to the other side, I got to add 12y to both sides of this second equation. And that will give me 6x plus 12y equals 24. Okay. Just to show you, 6x equals 24 minus 12y. I add 12y to both sides of the equation. That side that cancels out. Now I have 6x minus 12y on this side of the equation equals 24. Okay. And then 6x plus 12y equals 18. And I said already that I need to subtract these two equations to get the x terms to cancel out. Luckily, I don't have to change any signs. So 6x minus 6x is 0, 12y minus 12y is 0, and 18 minus 24 is negative 6. So I have 0 equals negative 6, which is a false statement. If everything cancels out and you're left with a false statement, that means these two lines never intersect, and there is no solutions. These are parallel lines. All right, last one. And I think I'm going to multiply the top equation by 2 and the bottom equation by 7. And then I'll have to move the bottom equation. I'm going to have to move the y term to the other side. And that will get my two equations in alignment. All right, so let's start multiplying. 14x plus 10y equals negative 26. negative 14x equals 49y plus, regretting the decision to multiply by 7. 26 times 7 is 182. Okay. Now, going to move this bottom equation around a little bit by, now I'm going to be moving the 49y. So I'm going to add 49 or subtract 49y from both sides. And I get negative 14x minus 49y equals 182. And I'm just going to bring my top equation over. 14x plus 10y equals negative 26. I'm going to add these two equations together, and the x's cancel out, which is exactly what I wanted them to do. 10y plus negative 49y is negative 39y. And negative 26 plus 182, it's 62, 156. All right. Divide by negative 39 on both sides. And y equals negative 4. If y equals negative 4, then I can plug it back into my original equation, 7 times x plus 5 times negative 4 equals negative 13, to solve for the other variable. 5 times negative 4 is negative 20. Add 20 to both sides. Divide by 7. The solution to this system of equations is 1, negative 4. I am your teacher. Sorry for the long video. This is the way.